In 1938, Wilhelm Koenig, the German director of the National Museum of Iraq, became aware that some of the jars in his museum's collection were not empty, but that each contained an iron rod within a copper cylinder. They were sealed at the top with asphalt, and the iron rod was isolated from the copper cylinder, which was crimped at the bottom. The jars were not watertight, however. A liquid poured into a jar would fill the tube as well, and there is evidence that the jars once contained something acidic. The combination of iron, copper, and an acidic solution is familiar to chemists. It is typical of a device in which chemical energy is converted into electrical energy. In other words, a battery. But the jars, collectively nicknamed the Baghdad Battery, could date back as far as 2,200 years. Given their age, could the jars really have been batteries? Is this an early form of electrochemistry? The interaction between chemical and electrical energy.
The artifact we're talking about has many interpretations, but because it contains all of the elements of electrochemistry, it has two different metals which are separated and it's in a sealed vessel. Many people have thought that it was just a very early form of the battery.
The particular combination of metals found in the jars, along with some other combinations, are known to produce a movement of electrons.
When you put an iron rod into a solution, the atoms on the iron rod will give up electrons and then get oxidized, turn themselves into an iron that will go to the solution. Well, the copper ions inside the solution will pick up the two electrons and get reduced into metallic copper, and that will be plated onto the iron rod.
As electrons flow from the iron to the copper, the newly formed iron ions go into solution. The solid iron rod slowly disappears.
The electrons flow from the iron to the copper. The iron goes from iron solid metallic iron to iron 3+. So that iron 3+ is soluble in solution. It'll dissolve away. So over time, this iron core will actually dissolve and disintegrate. That's the process that we call corrosion.
Corrosion explains why iron rusts and silver tarnishes. These are, in fact, electrochemical processes that occur anytime one element is ready to transfer electrons to another element ready to accept them.